Hello students, welcome to classes on computer organization. In this session, let us discuss about the execution of a complete instruction. So execution of a complete instruction. Complete instruction execution which involves two phases. One is fetch phase and other one is called as execute phase. Okay, fetch phase and execute phase. Here we are writing the set of micro instructions or sequence of steps. You should not change the sequence. See, sequence means what? Ordering one after the other, right? One after the other. What will happen after performing the first step, right? So it is very simple thing. If you want to write something on your notebook, what you will do? First step, you will open the notebook, right? Then you will use the pen or something else writing material you will hold, right? After that after that you will write, isn't it? So one after the other, how you are following or the order, right? In the same way, this sequence should be followed accordingly or appropriately. If you change the sequence, then meaning will be changed, right? Operation will be changed, the outcome will be changed. Please remember, this is one of the important, very important topic from this module. Sure question, right? Most expected question from this module.
So if you see the previous year paper, you can find out this question. Add R3, R1. Indirect mode is used. Recall first unit, first module concepts, right? Addressing modes. So indirection or pointer is used here, where R3 is the pointer register, right? Which holds the address of the what, right? You have to find the meaning is, you have to go through the content of R3 and it stores some location value. From that location, access the content, then add it with the existing content of R1. That's what the meaning of the statement, right? So see here, it is written there, which adds the contents of the memory location pointed by R3, right? Pointed by R3. That is identified, content is accessed, and it will be added onto register R1. So to execute this statement, compiler need to follow certain steps. What are the steps it is following? So the actions are written as a statement. Later on, let us consider the micro instruction or instruction set. The first one is fetch the instruction. Okay, fetch stands for read. Fetch the instruction. Fetch the first operand of the instruction. First is the fetching up of the instruction. That is reading the instruction, what is to be performed and all, since it is add instruction, right? Followed by read the first operand or fetch the first operand. Then next step is what? Perform the addition. Addition is because since the name of the operator we have used is add. So perform the addition. Finally, load the result or store the result onto destination operand. What is the destination operand? R1 is the destination operand, right? So these are the steps we are supposed to follow. Now it involves 7 different logical steps, okay, uh, where set of operations will be performed one after the other. First 3 steps out of 7, listen carefully, first 3 steps out of 7 is called as fetch phase. And please remember, whatever the instruction it may be, the fetch phase will be common. Okay, you are supposed to write these 7 steps in examination. Please remember, you are supposed to write these 7 steps in the examination. Okay, if the question is asked about the execution of a complete instruction, there are some certain tricks you need to remember and you have to follow. See, first 3 steps here stands for fetch phase. For a straight line sequencing, fetch phase remains the same throughout. Okay, that is nothing but reading the content from the program counter, updating the program counter, that's it. So updating the program counter is common for the straight line sequencing. Where it changes, then it changes only in case of branching, since For straight line sequencing, you are going to add a constant value 4. But for branching, wherever there is a branching in the next statement, then we are supposed to change it. Okay, that is different scenario. But most of the cases, the commonly asked question is the straightforward question. It is assumed that what? You are following the straight line sequencing, so fetch phase remains the same. First three steps remain same, whatever the instruction they give, let it be. Okay, please remember this sequence of steps of control statements. So first you are supposed to read the contents from program counter. So pc out, earlier in the previous session, those who have not watched the previous session videos, please watch. Right, each and every register will be having two gates. One is input gate, other one is output gate. What is input gate? pc in. If register name followed by in suffix stands for what? Input gating. You are providing or reading the data from bus, so bus to particular register. pc in is activated means, if pc out is activated means data is transferred from PC to somewhere else, right? So here PC out is activated followed by MAR in is activated. That means content from the program counter is transferred to memory address register. That's it, right? Perform the read operation, reading the location value. Then you are supposed to update the value of PC, isn't it? How it will happen? It will be happen with the help of the multiplexer. Read, go through the previous diagram. You will come to know. Yeah, let me consider that diagram also. See, select 4. From where select 4 is come? Then perform addition. Transfer it on to Z in. Let us open that diagram. See, this is the diagram. Which diagram? PC out. Okay, take the content from PC out, bidirectional arrow you can see, it is transferred on to MAR, right? PC out is transferred to MAR. That means the instruction which is to be executed is transferred to MAR. The location value of the instruction is transferred to MAR. That's it. Once the location value is transferred to MAR, program counter should be updated with the next value. That is what we are following in a fetch phase. Very simple to understand, right? Contents of PC is transferred to MAR. Now PC is updatable, right? Because its previous value is already stored somewhere. Now update the PC. How to update the PC? Question comes. Say whenever you are following the straight line sequencing, address of the next instruction is nothing but plus 4 with the existing value. What is plus 4? How to do that? See, right? Perform read operation, then transfer it on to select. Yeah, select constant 4 actually. So select 4 is considered with respect to multiplexer, right? Now PC out is transferred to Y in. Then you are supposed to select the constant value 4. So two outputs of multiplexer. Two inputs of the multiplexer. One is content of Y, other one is constant 4, right? Constant 4, content of Y and constant 4. Both the values should be added. Why it is to be added? It is to be added because what is multiplexer? Multiplexer is the one which takes multiple input and provides single output, right? Now see, this PC out is sent to MAR in, then PC is updatable, so you go for read operation, okay? Then select the constant value 4 on multiplexer. Existing value of PC out is already received in Z. Okay, go for addition, transfer it on to perform the addition with Z in. See here, no, this is a diagram. Yeah. Y has already received the content of PC out. Okay. Constant 4 you have selected. After that you have used this ALU for addition. Right. After that the computed result should be stored in which register? See the diagram. This diagram should be there in your mind. If you understand this diagram, rest of the things will be very easy for you. So after addition, the contents are stored in Z, right? So Z in is written, that's why. Next step is what? Next step is what? This Z should be transferred onto PC back. That's it. So Z out, PC in, that will come in the next step. Okay? See here. See here. Yeah. Z out, step number 2, Z out. Take the value from Z, updated value, it is actually a previous value of PC plus 4 it is now, right? Store it back onto PC, right? As well as on Y. So on both the locations it will be stored. Otherwise also it will come on to Y later on. Okay, it will be. Next step is what? This is done. The updation of the PC is done now. Now you are supposed to read the first operand, right? How to read the first operand? Sorry, you have to read the instruction. So how to read the instruction? Instructions will be stored in MDR. So MDR out, the data actually, memory data register, content of memory data register will be transferred onto instruction register. So these three stages, all steps, the sequence of steps, it is considered as the fetch phase. Okay, in the next video let us discuss about the execute phase. So step number 4 to 7 stands for the execute phase. Okay, please note down the things. This is very important question from this module.